TensorFlow hands-on for beginners introduction. TensorFlow is an open-source machine learning framework used to build, train, and deploy AI models. Beginners often learn TensorFlow to build image classification models, text classification models, prediction systems, recommendation models, deep learning applications, computer vision projects, natural language processing projects, real-world AI applications. A common learning topic is, how can beginners learn TensorFlow with hands-on projects? This guide explains. Perk, TensorFlow Basics, Machine Learning Fundamentals, Tensors, Datasets, Neural Networks, Model Training, Model Evaluation, Image Classification, Text Classification, Saving Models, Deployment Basics, Beginner Mistakes, Best Practices, Interview Questions. This is one of the best beginner-friendly guides for learning TensorFlow step by step. Simple definition. TensorFlow is a machine learning library that helps developers create and train AI models. Simple idea. Input data, TensorFlow model, prediction. Example. Image of cat, AI model, prediction, cat. Why beginners learn TensorFlow. TensorFlow helps beginners build AI projects, machine learning models, deep learning models, image recognition apps, text classification systems, prediction systems, smart automation tools. TensorFlow is commonly used in check healthcare AI, check finance AI, check e-commerce recommendations, check fraud detection, check bots, check computer vision, natural language processing, mobile AI apps. TensorFlow versus traditional programming. Traditional programming. Rules plus input equals output. Machine learning. Input plus output equals model. Example. Traditional programming. If image has whiskers and pointy ears, classify as cat. Machine learning. Show many cat images and dog images. Model learns patterns automatically. TensorFlow architecture overview. Basic TensorFlow workflow. Collect data, prepare data, build model, train model, evaluate model, make predictions, save model, deploy model. Step 1. Install TensorFlow. Install Python first. Then, install TensorFlow. Pip install TensorFlow. Check installation. Import TensorFlow as TF. Print tf.version. Expected output. TensorFlow version number. Step 2. Understand tensors. A tensor is a multidimensional array used by TensorFlow. Examples. Scalar. Import TensorFlow as TF. X equals tf.constant. 5 print x. Vector. V equals tf.constant. 1, 2, 3. Print v. Matrix. M equals tf.constant. 1, 2, 3, 4. Print m. Simple idea. Scalar equals single number. Vector equals list of numbers. Matrix, table of numbers. Tensor equals general multidimensional data. Step 3. TensorFlow basic operations. Example. Import TensorFlow as TF. A equals tf.constant 10. B equals tf.constant 20. Result equals A plus B. Print result. Output. tf.tensor 30. Shape equal dtype int 32. Other operations. TF add AB. TF subtract AB. TF multiply AB. TF divide AB. Step 4. Understand machine learning basics. Machine learning uses data to learn patterns. Basic terms. Term meaning dataset, collection of data. Feature, input value. Label, expected output. Model learns patterns. Training, learning process. Prediction, model output. Loss, error measurement. Optimizer, improves model. Example. Feature, house size. Label, house price. Model learns relationship between size and price. Step 5. Create your first TensorFlow model. Example. Predict simple numbers. Pattern. X equals 1, 2, 3, 4. Y equals 2, 4, 6, 8. The model should learn y equals x times 2. Code. Import TensorFlow as TF. Import NumPy as NP. Xtrain equals np.array 1, 2, 3, 4, 5. dtype float. Ytrain equals np.array 2, 4, 6, 8, 10. dtype float. Model equals tf.keras.sequential. tf.keras.layers dense units 1. Input shape 1. Model.compile. Optimizer SGD. Loss equals mean squared error. Model.fit. Xtrain, Ytrain. Epochs equals 500. Prediction equals model predict NP array 6. Expected result. Close to 12. Step 6. Understand Keras. Keras is TensorFlow's high-level API for building neural networks easily. Most beginners use TF Keras. Example. Model equals tf.keras.sequential. tf.keras.layers dense 10. Activation equals ReLU. tf.keras.layers dense 1. Keras helps with model creation, training, evaluation, prediction, saving models. Step 7. Understand neural networks. A neural network is made of layers. Simple architecture. Input layer, down, hidden layer, output layer. Example. Model is TF Keras sequential. TF Keras layers dense 16 activation ReLU. TF Keras layers dense 8 activation ReLU. TF Keras layers dense 1. Meaning. Perfect. First layer learns basic patterns. Hidden layers learn deeper patterns. Output layer gives final prediction. Step 8. Learn activation functions. Activation functions help neural networks learn complex patterns. Common activation functions. Activation usage, ReLU hidden, layer sigmoid, binary classification, softmax, multiclass classification, linear regression. Example. tf.keras.layers.dense, 16 activation ReLU. Step 9. Learn loss functions. Loss function measures model error. Common loss functions. Problem type, loss function. Regression, mean squared error. Binary classification, binary cross-entropy. Multiclass classification, sparse categorical cross-entropy. Example. Model.compile. Optimizer equals atom. Loss equals sparse categorical cross-entropy. Metrics equals accuracy. Optimizer improves the model during training. Popular optimizers. Optimizer, usage. SGD, simple beginner optimizer. Atom, most commonly used. RMS prop, good for some deep learning tasks. Example. Model, compile, optimizer, atom, loss, mean squared error. Simple idea. Loss tells how wrong the model is. Optimizer helps reduce the loss. Step 11. Understand epochs. An epoch means one full pass through the training data. Example. Model.fit, xtrain, ytrain, epochs equals 10. This means the model studies the full dataset 10 times. Too few epochs. Model may not learn enough. Too many epochs. Model may overfit. Step 12. Understand batch size. Batch size means how many samples the model processes before updating weights. Example. Model.fit, xtrain, ytrain, epochs equals 10, batch size equals 32. Common batch sizes. Check 16. Check 32. Check 64. Check 128. Step 13. Understand training and testing data. Do not train and test on the same data. Split data. Training data used to teach model. Testing data used to check performance. Example. Sub. From sklearn.model selection, import train test split. Xtrain, xtest, ytrain, ytest equals train test split xy, test size equals 0.2, random state equals 42. Common split. 80% training, 20% testing. Step 14. Evaluate the model. After training, evaluate performance. Example. Loss, accuracy, equals model.evaluate, x test, y test. Print loss, accuracy. Print accuracy for classification. Higher accuracy is better. For regression, lower loss is better. Step 15. Make predictions. Example. Prediction equals model predict, x test. Print prediction. For classification. Import numpy as np. Predicted class equals np.argmax prediction 0. Print predicted class. Step 16. First hands-on project. Image classification. Project. Classify handwritten digits using MNIST dataset. MNIST contains images of digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Architecture. Image dash TensorFlow model dash predicted digit. Code. Import TensorFlow as TF. MNIST equals tf.keras.datasets.mnist. X train y train x test y test equals mnist.load data. X train equals x train over 255.0. X test equals x test over 255.0. Model equals tf.kera.sequential. tf.kera.layers.flatten input shape 2828. tf.kera.layers.dense.128 activation equals relu. tf.kera.layers.ken activation equals softmax. Model.compile optimizer equals atom. Loss equals sparse categorical cross entropy. Metrics equals accuracy. Model.fit x train y train epochs equals 5. Loss accuracy equals model.evaluate x test y test. Print accuracy. Accuracy. Step 17. Understand image preprocessing. Images must be prepared before training. Common preprocessing. Color, resize images, normalize pixel values, convert labels, split train test data, augment images. Example, normalization. X train equals X train divided by 255. Y. Pixel values are usually 0 to 255. After normalization, 0 to 1. This helps the model train better. Step 18. Learn convolutional neural networks. CNN means convolutional neural network. CNNs are commonly used for image processing. Architecture. Image.conv2d.maxpooling.flatten dense output. Example. Model equals tf.keras sequential, tf.keras layers, conv2d 3233, activation is relu, input shape 28281, tf.keras layers, max pooling 2d 22, tf.keras layers flatten, tf.keras layers dense 64, activation is relu, tf.keras layers dense 10, activation is softmax. Used for image classification, image object detection, medical imaging, face recognition, OCR. Step 19. Second hands-on project, text classification. Project. Classify movie reviews as positive or negative. Architecture. Text review, tokenization, embedding layer, neural network, positive, negative. Example. Import TensorFlow as TF. IMDb equals tf.keras.datasets.imdb. X-train, Y-train, X-test, Y-test equals imdb.load-data numwords 1000. X-train equals tf.keras.preprocessing.sequences, pad sequences, X-train, maxlen equals 200. X-test equals tf.keras.preprocessing.sequence.pad sequences, X-test, maxlen equals 200. Model equals tf.keras.sequential, tf.keras.layers embedding 1016, tf.keras.layers.global average pooling 1d, tf.keras.layers.dense 16 activation relu, tf.keras.layers.dense 1 activation sigmoid. Model.compile Optimizer equals atom. Loss equals binary cross entropy. Metrics equals accuracy. Model.fit. X-train, Y-train. Epochs 10. Validation data. X-test, Y-test. Loss, accuracy equals model.evaluate. X-test, Y-test. Print accuracy. Accuracy. Step 20. Understand overfitting. Overfitting means model performs well on training data but poorly on new data. Example: training accuracy 98%, testing accuracy 70%. This means the model memorized training data instead of learning general patterns. Solutions: use more data, use dropout, use regularization, reduce model complexity, use early stopping, use data augmentation. Step 21. Use dropout. Dropout helps reduce overfitting. Example: model equals TF Keras sequential. TF Keras layers dense 128. Activation equals ReLU. TF Keras layers dropout 0.3. TF Keras layers dense 10. Activation equals softmax. Simple idea. Dropout randomly ignores some neurons during training. This helps the model become more robust. Step 22. Use early stopping. Early stopping stops training when performance no longer improves. Example: early stop equals tf.keras.callbacks.early stopping. Monitor equals val loss. Patience equals 3. Restore best weights. True. Model.fit. X-train, Y-train. Epochs equals 50. Validation data equals X-test, Y-test. Useful for 1. Avoiding overfitting. 2. Saving training time. Improving model quality. Step 23. Save a TensorFlow model. After training, save the model. Example: model.save mymodel.keras. Load saved model. Loaded model equals tf.keras.models.load mymodel.keras. Make prediction. Prediction equals loaded model predict X test. Step 24. Export model for deployment. TensorFlow models can be deployed in many places. Check backend APIs, mobile apps, web apps, cloud servers, edge devices. Common formats. Format usage. Keras, Keras model format. Saved model. TensorFlow serving. TensorFlow Lite. Mobile and edge. TensorFlow JS. Browser and JavaScript. Step 25. TensorFlow plus backend API. Typical architecture: front-end app, backend API, TensorFlow model, prediction response. Example: backend flow. User uploads image. Spring Boot or Python API receives image. Pre-process image. TensorFlow model predicts. API returns result. Response. Prediction: cat. Confidence 0.94. Step 26. TensorFlow with Python API. Simple Flask example. From Flask import Flask, request, Genify, import TensorFlow as TF. App equals Flask, name. Model equals tf.keras.models.loadModel, mymodel.keras. App at route, predict, methods equals post, def predict. Data equals request, get JSON. Prediction equals model predict, data input. Return, Genify, prediction, prediction.toList. If, name, equals main, app.run debug true. Architecture. React, mobile app. Flask prediction API. TensorFlow model. Step 27. TensorFlow plus Spring Boot integration. Spring Boot usually does not train TensorFlow models directly. Common architecture. Spring Boot backend, dash, Python TensorFlow service, dash, TensorFlow model. Spring Boot responsibilities. Hex, authentication, user management, business logic, database operations, file upload, calling prediction service. Python TensorFlow service responsibilities. Model loading, pre-processing, prediction, confidence score. Step 28. Real-world system design. Example: AI image classification system. Architecture. React front-end, Spring Boot API, file storage, Kafka event, Python TensorFlow worker, prediction result, PostgreSQL. User uploads image. Spring Boot stores image. Kafka sends image event. TensorFlow worker predicts category. Result stored in database. Frontend displays result. Step 29. TensorFlow project structure. Recommended beginner structure. TensorFlow project /data/notebooks/src train.py predict.py preprocess.py .evaluate.py /requirements.txt /readme.md. Benefits: clean code, reusable scripts, easier debugging, production-friendly structure. Step 30. Common TensorFlow packages. Package purpose. TensorFlow, main ML framework. NumPy, numerical operations. Pandas, data handling. Matplotlib, visualization. Scikit-learn, data splitting and metrics. Pillow, image processing. OpenCV Python, computer vision. Flask, prediction API. FastAPI, modern Python API. Level. Learn Python basics, tensors, Keras, dense layers, training loop, loss function, optimizer, model evaluation. Build number prediction model, intermediate level. Akama, image preprocessing, CNNs, text classification, dropout, early stopping, model saving, API integration. Build image classifier, text sentiment classifier, advanced beginner level. Learn transfer learning, TensorFlow Lite, TensorFlow serving, model monitoring, backend integration, batch prediction, production deployment. Build AI prediction API, recommended learning path, phase 1, Python and math basics. Learn check Python syntax, NumPy arrays, basic statistics, matrix basics, train test split. Goal: understand how data is represented before training a model. Phase 2, TensorFlow basics. Learn, ask. Check tensors. Check TensorFlow operations. Check Keras sequential API. Check dense layers. Check compile. Check fit. Check evaluate. Predict. Build simple regression model. Phase 3, classification. Learn labels, accuracy, softmax, sigmoid, cross-entropy loss, confusion matrix. Build digit classifier using MNIST. Phase 4, computer vision. Learn check image normalization, check CNN, check comp2D, check max pooling, flatten, data augmentation. Build cat versus dog classifier. Phase 5, NLP basics. Learn tokenization, padding, embedding layer, sentiment analysis. Build movie review sentiment classifier. Phase 6, deployment. Learn color, save model, color, load model, color, Flask API, color, fast API, color, Docker basics. Build TensorFlow prediction API, Java backend developer, learning path. For backend developers: Python basics, TensorFlow basics, model training, model saving, Python prediction API, Spring Boot integration, production deployment. Recommended stack. Check Python, TensorFlow, NumPy, Pandas, FastAPI, Docker, Spring Boot, PostgreSQL, Kafka, Redis. TensorFlow plus Spring Boot architecture. Recommended architecture: React frontend, Spring Boot backend, prediction service client, Python FastAPI service, TensorFlow model. Why this architecture is good: Spring Boot handles enterprise backend logic. Python handles machine learning model inference. Services are independently deployable. Easier scaling. Cleaner responsibility separation. Real-world example. AI resume screening system. Architecture: React UI - Spring Boot backend - resume upload API - file storage - Python TensorFlow service - prediction result. Features: Upload resume. Extract text. Classify resume category. Score candidate match. Save prediction. Show explanation. Admin dashboard. TensorFlow responsibilities. Text preprocessing. Text model inference. Text classification. Text confidence score. Backend responsibilities. Authentication. Authorization. File upload. Database storage. API response. Audit logging. Common beginner mistakes. 1. Not normalizing data. Bad. Xtrain equals Xtrain. Better. Xtrain equals Xtrain divided by 255.0. Normalization helps models train faster and better. 2. Training on too little data. Small data can lead to poor accuracy. Better. Use more data. Use data augmentation. Use transfer learning. 3. Ignoring overfitting. Always compare. Training accuracy, validation accuracy, testing accuracy. 4. Using too many epochs. Too many epochs can cause overfitting. Use. Check validation data. Check early stopping. 5. Not saving the model. Always save trained models. Model.save, model.keras. 6. Confusing regression and classification. Regression predicts numbers. Example. House price. Classification predicts categories. Example. Cat or dog 7. No proper evaluation. Accuracy alone may not be enough. Use. Precision, recall, F1 score, confusion matrix. Best practices. Start with small datasets. Normalize input data. Split train test data. Use validation data. Monitor loss and accuracy. Avoid overfitting. Save trained models. Keep preprocessing consistent. Use clear project structure. Use callbacks, like early stopping. Document model inputs and outputs. Deploy model behind an API. Test predictions with real examples. Version your model files. Monitor prediction quality in production. TensorFlow interview questions. 1. What is TensorFlow? TensorFlow is an open-source machine learning framework used to build, train, and deploy machine learning and deep learning models. 2. What is a tensor? A tensor is a multi-dimensional array used to represent data in TensorFlow. 3. What is Keras? Keras is TensorFlow's high-level API for building neural networks easily. 4. What is an epoch? An epoch is one complete pass through the training dataset. 5. What is batch size? Batch size is the number of training samples processed before the model updates its weights. 6. What is a loss function? A loss function measures how wrong the model prediction is. 7. What is an optimizer? An optimizer updates model weights to reduce loss. 8. What is overfitting? Overfitting happens when a model performs well on training data, but poorly on unseen data. 9. What is CNN? CNN stands for Convolutional Neural Network. It is commonly used for image processing tasks. 10. How do you save a TensorFlow model? Using model.save, model.keras, TensorFlow versus PyTorch. Feature, TensorFlow PyTorch, API style, Keras high-level API, Pythonic and flexible, beginner-friendly, very good with Keras, very good production, strong deployment ecosystem, strong research and production use, mobile TensorFlow Lite, PyTorch Mobile, Executorch, production ML, mobile ML research, experimentation, production TensorFlow versus scikit-learn. Feature TensorFlow, scikit-learn. Best for deep learning, traditional machine learning, neural networks, strong. Limited image processing, strong. Not ideal text. Deep learning, strong. Basic beginner use. Deep learning projects, ML basics. Deployment, TensorFlow serving. TF Lite Python APIs, TensorFlow project ideas, beginner projects. Con, simple number prediction. Con, handwritten digit classifier. Con, flower classification. Con, house price prediction. Con, sentiment analysis. Intermediate projects. Cat versus dog classifier. Spam message classifier, product review classifier, image recognition API, stock price trend classifier, advanced beginner projects, transfer learning image classifier, resume classification system, medical image classifier demo, TensorFlow Lite mobile model, fast API prediction service, 30-day learning plan, week 1, TensorFlow basics, learn. Check tensors, NumPy, Keras, dense layers, compile, fit, evaluate, predict, practice. Check build simple regression model. Check predict numeric values. Week 2, classification, learn. Labels, softmax, sigmoid, cross-entropy, accuracy, confusion matrix. Practice. Check build MNIST digit classifier. Check test predictions. Week 3, image and text projects. Learn. Coral, image preprocessing. Carl, tokenization. Embedding layer. Dropout. Early stopping. Practice. Check build image classifier. Check build sentiment classifier. Week 4, deployment. Learn. K. Save model, load model, Flask or Fast API, Docker, API design, Spring Boot integration. Practice. Create prediction API, create prediction API from backend. TensorFlow hands-on checklist. You should be able to C. Install TensorFlow. C. Create tensors. Build a Keras model. C. Compile a model. C. Train a model. C. Evaluate accuracy. C. Make predictions. Build image classifier. Build text classifier. Reduce overfitting. Save and load model. Expose model through API. Integrate with backend services. Final summary. TensorFlow is a powerful framework for building machine learning and deep learning applications. Important beginner concepts include CUC, tensors, Keras, neural networks, layers, activation functions, loss functions, optimizers, epochs, batch size, model evaluation, image classification, text classification, model deployment. Backend developers already understand, APIs, data processing, system design, databases, deployment. This makes TensorFlow easier to connect with real-world backend systems. Key idea. TensorFlow helps beginners build AI models that can learn patterns from data and make predictions in real-world applications.